All right, so here we are doing some subscript notations to start with. So we're looking at x sub 1. X sub 1 means we have the first term in our set of numbers. So the first term is 6. What is represented by x sub 4? That's going to be our fourth term. So 1, 2, 3, 4 is going to be 3. What symbol would be used to represent the number 7 in the list? Number 7 is the third term, so it will be x sub 3. And what number is n in x sub n? So x sub n is always going to be your last term. It's not going to be equal to 9. X sub n is the x sub nth term is 9, but n is 1, 2, 3, 4, 5, 6, 7. It's the 7th term. So n is equal to 7. So that's all you have to do on that is figure out what the term is and where does it land. So now we're going to use those same data points and we're going to answer a few questions. So finding the summation of x. So these are our x up here and we're going to find the summation of it. So if we're looking for the summation of x, that means we're just going to add those numbers together. So we are looking at 6 plus 5 plus 7 plus 3 plus 8 plus 2 plus 9. And when we add those all together, we should get 40. The next thing we're going to do is find the summation of x minus 3. So that means we're going to take 3 away from each of our terms. So we're going to have 6 minus 3 plus 5 minus 3 plus 7 minus 3 plus 3 minus 3 plus 8 minus 3 plus 2 minus 3 plus 9 minus 3. All right, so 6 minus 3 equals 3. 5 minus 3 is 2. 7 minus 3 is 4. 3 minus 3 is 0. 8 minus 3 is 5. 2 minus 3 is negative 1. And 9 minus 3 is 6. And when we combine all those numbers together, we should end up with 19. All right, the next one we need to find is the summation, this will be part G, of 2x. That means we're going to multiply each of the terms by 2 and then add them together. So 2 times 6 plus 2 times 5 plus 2 times 7 plus 2 times 3 plus 2 times 8 plus 2 times 2 plus 2 times 9. So 2 times 6 is 18, plus 2 times 5 is 10, 2 times 7 is 14, 2 times 3 is 6, 2 times 8 is 16, 2 times 2 is 4, and 2 times 9 is 18. And when we sum those all together, we should end up with 80. Our next one is the summation of x minus 4 quantity squared. So what we're going to do is still plug in all of our same values and we're going to subtract 4 and then we're going to square it. So we're going to have 6 minus 4 squared plus 5 minus 4 squared plus 7 minus 4 squared plus 3 minus 4 squared plus 8 minus 4 squared plus 2 minus 4 squared plus 9 minus 4 squared. So 6 minus 4 will get us 2 squared plus 5 minus 4 will get us 1 squared. 7 minus 4 will get us 3 squared. 3 minus 4 will be negative 1 squared. 8 minus 4 will be 4 squared. 2 minus 4 will be negative 2 squared. 9 minus 4 is 5 squared. So 2 squared is 4. 1 squared is 1, 3 squared is 9, negative 1 squared is negative 1 times negative 1. That'll get us positive 1. 4 squared is 16. Negative 2 squared is negative 2 times negative 2, so it'll be positive 4. And 5 squared is 25. Now when we add all of these together, we should find that our answer is equal to 60. All right, so the next one we're going to do will be the last one we do with our set of data here. And we're going to find the square root of the summation of x minus 2 divided by 8 minus 3. So on this, you're only going to have one radical sign, and you write it as one whole problem, just like we've done in the past. All right, so summation, again, it still means we're adding, but we have to subtract 2 from each one. So 6 minus 2 plus 5 minus 2 plus 7 minus 2 plus 3 minus 2 plus 8 minus 2 plus 2 minus 2 plus 9 minus 2 all over 8 minus 3 is 5, and that is all under the radical. It's only one radical, not multiples of them. All right, so 6 minus 2 is 4, 5 minus 2 is 3, 7 minus 2 is 5, 3 minus 2 is 1, 8 minus 2 is 6, 2 minus 2 would be 0, and 9 minus 2 is 7, all over 5 underneath our radical. All right, when we add our 4 plus 3 plus 5 plus 1 plus 6 plus 0 plus 7, we get 26 over 5 underneath our radical. So 26 divided by 5, you can put that all in the radical, or you can take it down to a decimal of 5.2. Either way will work. And now take the square root of that is 2.28. And that would be your final answer for that. So we have one more summation problem. It just doesn't involve the set of data. So this will be the first part and 2, part A. We have the summation from I equals 1 to 6 of 5I minus 2. So that means we're going to plug in the numbers 1 through 6 and find the summation of it. So we're doing basically the same thing we did before. So we're going to have 5 times 1 minus 2 plus 5 times 2 minus 2 plus 5 times 3 minus 2 plus 5 times 4 minus 2 plus 5 times 5 minus 2 and plus 5 times 6 minus 2. So 5 times 1 is going to get us 5. So now we will have 5 minus 2 plus 5 times 2 is 10 minus 2. 5 times 3 is 15 minus 2. And I'm going to keep these kind of grouped together just so we can see where they're coming from. 5 times 4 would be 20 minus 2. 5 times 5 would be 25 minus 2. And 5 times 6 is 30 minus 2. So 5 minus 2 would be 3, 10 minus 2 is 8, 15 minus 2 is 13, 20 minus 2 would be 18, 25 minus 2 would be 23, and 30 minus 2 would be 28. When I combine all of these numbers, we are going to find that we end up with 93. So that's the end of the summations we're going to look at. Next, we're going to look at some radicals. So for our radicals, we are just looking for decimal approximations. So for part B on 2, we are just going to take the square root of 41. So when I take the square root of 41, On my calculator, it'll give me the exact, I need to hit this other double arrow button, and that will give me my decimal, 6.4031. We're going to go to 2 decimal places, so we'll end up with 6.40. So we're using our rounding rules. It'll stay 0 because after the 0 was a 3, so it won't round up. Now we're going to take the square root of 538.6, or 0.26, second square root of 538.26. Again, we end up with 0 after it, so it won't round. It'll just say 23.20. Part D, we have the square root of 21 over 3. Well, that reduces to the square root of 7. And taking the square root of 7, I have to hit my double arrows again. So we end up with 2.645. Well, the 5, using our rounding rules, 5 or greater, we round up. So that 5 will cause the 4 to become a 5. So it'll be 2.65. Our next one, we have the square root of 16 plus 5 over 6 minus 2. Well, 16 plus 5 will get us 21. 6 minus 2 is 4. If we take 21 divided by 4, we can end up with 5.25. We wouldn't want to round early, but it actually becomes that. And if we take the square root of 5.25, we see we get 2.29. The one after will keep it the same. And I can show you, you can also take the square root of 21 divided by 4, and you get the same answer. So you can do it either way. So our answer will be 2.29. Our last one has the square root of 15 minus 3 squared over 8 minus 5. So 15 minus 3 would get us 12 squared. 8 minus 5 is 3. So we end up with the 12 squared is 144 divided by 3. That is actually 48, so it'll be the square root of 48. And when we put the square root of 48, we end up with this, but I'm looking for decimals in this class, not the exact value. So we're looking for 6.92, but the 8 after will cause it to round up, so our answer will be 6.93. All right, so the next thing we're going to talk about is the fundamental counting principle. So there's a diner that offers a dinner special where you can select an appetizer, entree, and dessert for $11.99. Given that there are 5 appetizers, 9 entrees, and 6 desserts to choose from, how many different course meals are there to choose from? So there were 5 appetizers, 9 entrees, and 6 desserts. So we're going to multiply those 3 things together. So we had 5 appetizers times 9 entrees times 6 desserts, and that will get us 270. So that tells us there's 270 different ways to order that meal. You may order the same thing except change the dessert, change the entree, or change the appetizer, but there are 270 different ways to do it. All right, so Sue has 9 shirts. She has 6 pairs of pants and 7 pairs of shoes. How many different outfits can she wear? So we're going to take 9 times 6 times 7, and that'll get us 378. She may only change her shoes, but she still has 378 different ways that she could wear her clothes. So how many possible passwords can you make that consist of 3 lowercase letters and 4 numbers? If the numbers and letters can be repeated. So for the passwords, you need to know how many letters are in the alphabet. So there are 26 letters. There's 26 lowercase, 26 uppercase. That's why they're specifying. And for numbers, we need to know how many single-digit numbers there are. Usually we think that there's 9, but there's really 10 because 0 is included in that. So we had 3 letters, so it'll be 26 times 26 times 26, and there's 10 numbers, 0 through 9, and there's 4 of those, so it'll be 10 times 10 times 10 times 10. And that will get us 175,760,000. So 175,760,000 different ways that you can do the passwords. All right, if Bill has at least $50 in his pocket, how much money could Bill have? Well, if he has at least $50, so he knows he's got 2 20s and 2 5s. So that ends up to be $50. He knows he's got at least that, but he thinks he has some 1s in there. So he's got at least 50, or he could have more money. So how much money could he have? It's $50 or more. If Sue has at most 7 pairs of shoes, how many pairs of shoes does Sue have? So she knows she's got at most 7, but she's thinking she might have less than that. So this is going to be 7 pairs or less. So if he has at least 50, it's 50 or more. If she has at most 7, she has 7 or less. So that's all that you would write on that. So for part A, you would write 50 or more. And for part B, you would write 7 or less. They kind of go opposite of what the words look like. All right, so we have some data given, and we are answering the questions based on this data about earthquakes. So how many earthquakes were at least 6.0? And this was in 1998 with the data given. So at least 6.0 means 6.0 or more. So 6.0 is here, so it's going to be 113 plus 10. Let's switch this up. So for part A, we will have 113 plus 10, which will get us 123. For part B, how many earthquakes were at most 2.9? So that means 2.9 or less. So we have 3 numbers here that we need to add. We have 3851 plus 752 plus we have 2389. And when we add those together, we will find that we have 6,992. How many earthquakes were at least 3.0 but no more than 4.9? So at least 3.0 but no more than 4.9. We're going to add this one, 5639, plus this one of 6943. And we will get 12,582. All right, so the next question we're going to ask about has to do with estimation and if something is reasonable. So we went to the grocery store and we purchased some milk, some shampoo, some cookies, some bread, and soda. We want to estimate the amount you think you should pay at the register and then find the actual total cost of the items. So this is number 6, if you're in my class. And so we're estimating. So for $2.47, we are going to estimate to the nearest dollar. So that means if it's 50 cents or more, we'll go up. If it's less than 50 cents, we're going to go down. So $2.47, that'll round down because it's less than 50 cents on that part, to 2. For $1.93, we are going to round up to 2. For $3.75, that will round up to be 4. For $1.27, that will round down to 1. And for soda, for the $2.53, it's going to round up, because it's 50 cents or more, to 3. So when we add this, we get 2, 4, 4 plus 4 was 8, 9, 10, 11, $12. And if we actually add the actual amount, we find that it is $11.95. So is our estimation of $12 reasonable? Well, yes, it is. So that's what you're looking for. As long as it's within $1 or $2 on these small amounts, you're okay. All right, so our next question, we are going to do some conversions. So we're going to convert some increments. So we are going to convert 45 feet to centimeters. So we're going to convert 45 feet to centimeters, which means we're going to start with 45 feet. And we need to know anything on the test will be provided formula-wise as far as the conversions that you'll need. So if we have 45 feet, and I want to go to centimeters, there's not a conversion from feet to centimeters, but there is from inches to centimeters. So I need to take feet and get it to inches. And you can put that over 1 if that helps you. So if I want to go from feet to inches, the feet has to be where I can cancel them up and down. They can't be matching on both on the top. So I can go from feet to inches, and in 1 foot there are 12 inches. Now I need to go inches to centimeters. So in 1 inch, there are 2.54 centimeters. So now my inches will cancel, and I'm left with centimeters. So now I have 45 times 12 times 2.54 centimeters. And everything on the bottom is a 1 or it canceled out, so it won't really make a difference. So we have 1,371.6 centimeters are in 45 feet. You need to make sure you use the increments. And it helps if you can see what I'm doing. Sorry about that. All right, let's look at the next one. So part B. So we are going to take 2,634 yards to miles. So we'll start with our 2634 yards. And we can put that over 1. You don't have to, but sometimes it helps it make it easier. And we're going to yards on the bottom. We got to go to miles. We don't know how many yards are in a mile, but we can know how many feet are in a mile. And we know how many feet are in a yard. So for each yard, there are 3 feet. So now my yards will cancel. So that tells me my feet have to be on the bottom because it needs to be able to cancel. And I can do the feet in a mile. Mile is my bigger increment, so it's going to be a 1 on the top, and there are 5,280 feet in a mile. So that's 5,280. One of my students taught me that is 5 tomatoes. So 5 tomatoes is 5,280. She learned it from another instructor, and it stuck with me. I always remember now how many feet are in a mile. So now we have 2634 times 3 divided by 5,280, and this will be miles. So on the top, we then we can take this whole thing and multiply it and divide it. So we would end up with 2634 times 3. So we have 7,902 over 5,280 miles. And that's going to get us 1.49659. Just to kind of show you the decimal places, we want to go to 2 decimal places. So that means our 6 will make the 9 become a 10, and the 1 will then carry over, so it's going to be 1.50 miles. That would be your final answer. And make sure you have the measurement, like I said. All right, the next one we're going to do is 5 hours, 2 seconds. So we're going to start with 5 hours. And we know the hours are going to have to go there. We can't do hours to seconds, but we can go hours to minutes. And we know in 1 hour there are 60 minutes. And then I can take minutes to seconds, and we know in 1 minute there are 60 seconds. So we'll have 5 times 60 times 60, and our hours canceled, our minutes canceled, we're left with seconds. And when we multiply that out, we will get 18,000 seconds in 5 hours. All right. We've already talked about the rounding, so we'll talk just very briefly about it. So again, you're following the 5 or more. We're going to round to 2 decimals. 5 or more, we round up. This is a 5, so that would cause the 4 to round up. So we'd have 86.75. For this one to 2 decimal places, we care about the 6 and the 3 that's after it. The 3 after it doesn't change it, so it'll stay at 38.96. And this one, 7239.658, the 5 after the 5 is an 8, so the 8 will cause the 5 to round up, so we'll have 7239.66. All right, we have 2 more problems. We are going to compute some factorials. All righty, so for part A, we have 32 factorial over 29 factorial. So remember that with your factorials, that means it's being multiplied every number from that number all the way down to 1. So 32 is 32 times 31 times 30 times 29 times 28 times 27 times 26, all the way down to 5 times 4 times 3 times 2 times 1. 29 is going to be multiplied by 28 times 27 times 26 times 25, all the way down to 5 times 4 times 3 times 2 times 1. So when we're simplifying our factorials, we can stop where the other one starts. So I can do 32 times 31 times 30 times 29 factorial over 29 factorial, because both of these will mean that we're multiplying all of the numbers below it. So those will cancel, and we're left with 32 times 31 times 30, and when we multiply that out, we will end up with 29760. And then the last problem, we have 21 minus 8 factorial over 6 factorial. So first we have to do our subtraction. So 21 minus 8 will get us 13 factorial over 6 factorial. So that means we're going to take 13 all the way down to 6 factorial. So we have 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. Those will cancel. And we have 13 times 12 times 11 times 10 times 9 times 8 times 7, which will then get us 8,648,640. So 8,648,640.